Hi, future doctors. Welcome to the next class. In this class, we will discuss about electric potential. So, what is the electric potential? So, generally, in common words, we will use you will have that caliber, you will have that potential. So, for what you have that caliber or potential means to do some amount of work done. So, what is the work done here means if you are taking a point charge here. So if you want to do a positive test charge, if you want to bring a positive test charge from infinite distance to a point, where this point you have to take means within the electric field region of this charge. This charge will produce some amount of electric field. So for positive charge, how the direction of electric field, it will be away. For negative charge, it will be towards. So if you are bringing this positive charge up to this point P, which is at distance small r, which is at distance small r. So you have to do some amount of work done. So that's the definition we will write like this generally. V is equal to W by Q naught. The amount of work done to bring positive test charge, unit positive test charge. If we are having very small distance, dx, very small distance dx, then voltage potential is also going to be at the time dV is equal to dW by Q naught, isn't it? Like this also we will write. Next, this is general definition of voltage. What is the unit for this? Joule per coulomb. Dimension formula also you will write. What is Joule dimension formula? mL square T power minus 2. Joule is nothing but unit of energy. Coulomb. What is Coulomb dimension formula means? AT. So if you want to write final dimension formula, m L square T power minus 3 A power minus 1. Okay. So this is the dimension formula for potential or voltage. So this joule per coulomb only we will write generally volts. So that volt symbol we are going to represent V. Okay. This is about definition of the potential. Next, potential due to point charge at some distance. So if you are taking Q charge at a distance r, what is the electric field intensity at this point P we wrote? E is equal to kq by r square. Now what is the potential at this point? Potential at this point is going to be V is equal to kq by r. Just you have to write r. Kq by r square if you write, that is electric field. Kq by r if you write, that is going to be potential. Okay, actually derivation also will be there for this big derivation. Here we are not using the derivation because in between equations you won't get anywhere while solving the problems. But some derivations I am doing because those derivations will be helpful for solving the problem. Therefore, that difference you people should understand. If you are taking positive charge plus Q at some distance r at this point P, what is the potential due to positive charge means kq by r. Just you have to remember. If we are taking negative charge minus q at some distance r at this point P, so what is the potential means minus kq by r. But in case of electric field, if you are taking positive charge, electric field direction will be away. It is going to be away for positive charge. E is equal to kq by r square. This is magnitude. So if you are taking negative charge minus q, electric field intensity will be towards at some distance r, kq by r square. This is magnitude. See direction. For this it is going to be right side, I cap. For this it is going to be left side, minus I cap. In a electric field formula, we will write by multiplying r cap. That is different. Just here I am saying for direction, how it is going to come. In case of potential, how it is going to be referred. So now another definition in this, potential difference. Potential difference. So what is the potential difference means? If you are taking a positive charge plus Q, its electric field intensity is going to be away. So the amount of work done to bring a unit positive test charge from A to B against to the direction of electric field. Electric field is always away for positive charge. We are bringing a unit positive test charge from B to A. Then you have to do some amount of work done. This difference only we will write potential difference. VAB is equal to W by Q naught. So VAB is going to be W by Q naught. So this VAB gives potential difference between A and B. So VA minus VB, like relative velocity, you will write now, same like W by Q naught. This is the work done to bring a unit positive test charge from B to A. Okay, this is nothing but potential difference. Potential difference will be coming whenever you are bringing charge from one point to another point within the electric field. What is potential? We said the amount of work done to bring a charge from infinite distance to a point within the electric field. So in previous slide we have discussed this point P will be within the electric field. We brought this charge from here to here. So but here we brought charge from one point to another point within the electric field. In any direction you can bring. Now we will use these formulas for solving the problem. So we give which formulas means these formulas finally you people should remember. So V is equal to W by Q naught. dV is equal to dW by Q naught for small amount of work done. Next, what is the potential difference we said? That is also W by Q naught. So this difference only we will write VA minus VB, W by Q naught. Another one for positive charge. For positive charge at some distance R, KQ by R. For negative charge, minus KQ by R. All these we discussed. This potential is going to be scalar. It is not a vector. But electric field is vector, isn't it? This is potential equation. Now from this equation, you can observe what is W we said? Q naught into V. So what is force on charge in electric field we said? F is equal to Q into E. Same like that, W is equal to Q naught into V. So again work done if you go for first year. What are the work done equations from first year? You people came to know. F bar dot S bar is equal to Q naught V. So like this they are going to ask work done. So according to work energy theorem, work done can be written as half mv square minus half mu square is equal to Q naught V. So these are the formulas. So now with these formulas, we have to do the problems. How to solve the problems? So we will discuss in our next class. Now you should be perfect on this. So who are preparing for board exams? For the board exam people, this potential due to point charge, this KQ by R formula derivation also important for those board people. But in the derivation, any equation in between whichever equation is coming, we won't use anywhere for problems. Therefore, I am not doing the derivation, but prepare the derivation for board exam who are preparing for board exam. For competitive, so you should play. You will have to play with these equations. So be ready after preparing by remembering these equations. Then how we have to apply these equations, we will discuss in our next class. Okay.